Centrifugal pumps are most commonly used turbo-machinery devices, which are used to raise pressure, or induce flow in a control volume. They are radial flow devices. Various kinds of centrifugal pumps are available in market, with different construction details, but working principle behind all of them remains same. In this video we will analyze working principle of a centrifugal pump with single suction, semi-open impeller. One of such pump is shown in figure, with one part of its casing removed for ease of understanding. Working of centrifugal pump is simple. As the impeller rotates, it sucks fluid from outside through eye of impeller. The fluid is pushed radially along the impeller to the casing. Casing collects the fluid, and it is pumped out through discharge nozzle. We will go through main components of a centrifugal pump in a detailed way. First, impeller. Impeller is the device which rotates and transfer energy to fluid. It has got collection of vanes fitted to a hub plate. Next component is casing, which collects fluid from impeller in an efficient way. The casing has got a special shape, with area of cross-section increases from inlet to outlet. As the impeller ejects fluid throughout casing, a long length of casing mass flow rate increases. But, increasing area of casing helps in maintaining almost same velocity. Thus volute-shaped casing helps in converting dynamic part of fluid energy to static part. It will be interesting to know about construction details of volute casing. Casing is made on two volute curves, which are at offset. A three-dimensional volute is made from these curves. A portion is removed from volute shape, in order to accommodate the impeller in it. A discharge nozzle is fit at exit portion of the casing. Most of the time discharge nozzle is diverging in shape. For centrifugal pumps of small capacity, as we discussed, impeller and casing are its main components. But, for larger centrifugal pumps, there will be additional diffuser blades also present, in order to reduce velocity further. Or, they aid in dynamic to static energy conversion. Now, we will see how to predict pressure rise. Blade velocities, at inlet and outlet are shown here. Fluid velocities at inlet and outlet are also marked. Here you can see, fluid velocity increases from inlet to outlet, due to energy addition to fluid. The work required for changing inlet velocity condition to outlet, is given by this equation. We will go through such turbo machinery analysis in a separate video. Here Q is the flow rate, and V theta represents tangential velocity component of flow. For a centrifugal pump, inlet velocity will be parallel to radius, so tangential component at inlet is 0. From here we can find what's the head rise in meters of fluid. Outlet blade angle beta can be derived in terms of velocities. Also flow rate through impeller is given as flow area times radial velocity. So head rise in a centrifugal pump can be derived in terms of flow rate. Using this we can predict what's the head rise, as we change the flow rate, for a particular pump geometry, and a particular impeller angular velocity. Most important parameter in this equation is blade outlet angle, beta. There can be three different pump characteristics depending upon value of this angle. First case, if beta is less than 90 degree. Since this term is positive in this case, pressure head decreases, with increase in flow. These kinds of impellers are called backward curved. If beta is 90 degree, with flow rate, there is no change in pressure rise. Because this term is 0 here. They are called radial type. If beta is more than 90 degree, pressure increases with increase in flow rate. Such blades are called forward curve blades. The big question, out of these which one is the most suited for industrial use? To get answer for this question, Let's see how power consumption varies with discharge, for each of these cases. For backward curved blades, as pressure head decreases with discharge, power consumption stabilizes with flow. In radial blades, since pressure does not have any connection with flow rate, power consumption increases linearly. In forward curved blades, since pressure head increases with flow, power consumption increases exponentially, making the operation unstable. This will lead to burnout of motor. So backward curved blades, which has got self-stabilizing characteristics, in power consumption is the most preferred one in industry. To know more practical aspects of centrifugal pumps, check the second video. Thank you.